The R-4 was the first production helicopter in history.
Sikorsky delivered the initial batch to the United States Army Air Force in 1944, and from the moment of the plan, it clogged him in the battle.
The R-4 had no stability in the hover.
Any gust of wind, any overcorrection on the cyclic, and the aircraft would begin to oscillate at missiles.
There were no manuals worth following, no instructors with real experience, and no margin for error.
Training accidents were not exceptions. They were expected.
When the H-19 entered service in 1950, the Army believed it had finally produced a helicopter that could be trusted. It was larger than anything before it and powerful enough for real utility work. The pilots disagreed and ran hot under sustained load. In field conditions, the warning signs were easy to miss until it was too late. Engine fires during routine operations and training flights. The hover was unstable in crosswinds and the controls required constant physical correction that fatigued pilots on longer sorties. The transmission system ran hot under sustained load, and in field conditions, the warning signs were easy to miss until it was too late.
Engine fires were not theoretical.
They happened during routine operations and training flights.
The hover was unstable in crosswinds and the controls required constant physical correction that fatigued pilots on longer sorties.
The H-19 trained a generation of helicopter crews.
Many of them spent years wondering when the machine beneath them was going to stop cooperating.
The Soviet Union watched the Korean War and understood that the Americans had found something useful in the helicopter. A large piston engine transport that entered service in 1952 and was sent everywhere the Red Army needed it. The aircraft worked. It carried troops, evacuated casualties, and supplied remote positions.
But the transmission was its permanent weak point.
Under sustained load in hot conditions, it ran hot and rough.
Soviet maintenance crews developed an informal familiarity with transmission failures.
It was reliable enough to fly. It was never reliable enough to relax.
The K-15 was the Soviet Navy's first purpose-built shipboard helicopter, entering service in 1956. In wind and naval operations rarely happen in calm conditions, the aircraft became extremely sensitive to gusts across the deck,
requiring precise and immediate correction.
Britain licensed the Sikorsky H-19 and built it as the Whirlwind.
The Rolls-Royce Gnome engine installed in early British variants proved significantly less reliable.
Royal Navy crews operating from ships found themselves flying an aircraft whose engine they did not fully trust over water.
It ran rough, it ran hot, and it had a tendency toward power loss at moments that left pilots with very limited options.
Royal Navy crews operating from ships found themselves flying an aircraft whose engine they did not fully trust over water with no realistic emergency alternative.
The H-21 arrived in Vietnam in 1962 as one of the first American helicopters committed to the war. The country immediately exposed everything the aircraft could not do. In the heat and humidity of Southeast Asia, the H-20 at precisely the moments it needed it most. Heavily loaded in hot weather over jungle terrain, the aircraft struggled to climb and struggled to accelerate. Pilots learned to calculate loads conservatively and accept that the machine had a ceiling well below what the specifications suggested. The HH-43 used an intermeshing rotor design, two rotors crossing over each other without a tail rotor. The handling characteristics were unlike anything pilots had trained on. Transitioning to the Husky required relearning reflexes.
The aircraft was used extensively for crash rescue at air bases across Southeast Asia.
The pilots who flew it also spent considerable time warning newcomers that the first hours in the Husky were going to feel deeply wrong. The CH-37 was the largest helicopter in the American inventory when it entered service in 1956. Sikorsky's solution to engine placement was to mount them in sponsons on either side of the fuselage. In operation, the sponson-mounted engines created persistent problems with heat management and fire risk. Engine fires in the CH-37 were not theoretical events. They happened often enough that pilots developed informal procedures. The AH-1G entered combat in Vietnam in 1967 as the Army's first purpose-built attack helicopter. In lowland heat at high humidity, heavily loaded with weapons and fuel, the Cobra's single Lycoming T-53 engine struggled. Pilots flying fire support in the Mekong Delta found the aircraft would not hold altitude in a loaded hover. The CH-46A entered Marine Corps service in 1964. Within 2 years of combat operations in Vietnam, it had accumulated a record that no manufacturer would have chosen. In 1967, a series of structural failures, the aft pylon separating in flight, killed multiple crews and grounded the entire fleet.
The transmission was unreliable,
under sustained combat loads. The engines ingested dust and lost power. Marine pilots who flew the CH-46 in Vietnam later described a learning curve that was deadly.
On March 12, 1969, Lockheed test pilot David Beale took the third H-56 Xi'an prototype over the California coast.
The main rotor blades began oscillating vertically, an instability the program had been working to eliminate for months.
The oscillations grew until the blades struck the tail boom and the cockpit simultaneously. Beale was killed instantly. The Mi-4 was a small twin-turbine helicopter built in Poland under Soviet license.
The cyclic was extraordinarily sensitive, responding to inputs that would have been negligible in any other aircraft. A touch too much input and the aircraft moved sharply. A correction applied too firmly and the oscillation began. The K-25 entered Soviet naval aviation in 1965 as a shipboard anti-submarine helicopter. Pilots transitioning from conventional single-rotor helicopters encountered a control system whose logic was not entirely familiar.
Soviet naval aviators operated the K-25 in North Atlantic conditions in weather that challenged any aircraft.
The Mi-4 was the largest production helicopter in the world when it entered service in 1959.
At maximum takeoff weight, the aircraft had inertia that pilots described as flying a building.
The Mi-6 used stub wings to offload the rotor in cruise flight, which helped with range but added another variable to manage.
The Mi-10 was a flying crane, a conventional rotor system mounted on 4 long legs designed to straddle outsized cargo.
Landing on a precise point while looking through a glass panel in the floor at a load they could not directly see.
The test pilots who flew it described the handling in terms that conveyed scale rather than precision.
The CH-54 was the American flying crane, and its defining operational challenge was the precision landing under load.
The pilot sat backwards, looking down and aft through a window at the load below.
Army pilots who flew the CH-54 in Vietnam, lifting artillery pieces and downed aircraft from jungle terrain, described Riveted in 3.
The early CH-47 variants that entered service in the mid-1960s had a vibration problem that was structural rather than incidental.
The tandem rotor system produced resonance frequencies that transmitted through the airframe.
Several early aircraft were lost when structural failures resulted from vibration damage.
The CH-53A was the most powerful helicopter in the Western world when it entered service in 1966.
Its capability came with physical demands that pilots felt across the length of every mission. Vibration in the early variants was significant, a continuous low-frequency transmission through the airframe that fatigued crews.
The Mi-8 became the most widely produced helicopter in history. Afghanistan changed the assessment. At altitude, the engines lost power.
Heavily loaded for combat resupply or casualty evacuation, the aircraft struggled to climb and could not hover out of ground effect. Soviet after-action reports from the Afghan campaign document a sustained pattern of performance limitations that forced crews to recalculate loads constantly.
The Mi-24 was one of the most feared combat helicopters ever built.
The tandem cockpit arrangement and armored glass severely restricted forward and downward visibility.
In the mountains of Afghanistan, where terrain came up fast and level flight has an awareness of everything below and ahead, this was the primary tactical problem.
The Wessex entered Royal Navy service in 1961 as a license-built version of the Sikorsky S-58.
Westland replaced the original piston engine with a Rolls-Royce Gnome turboshaft that changed the aircraft's handling characteristics.
In auto-rotation, the Wessex required precise timing and technique that was less forgiving than comparable aircraft.
The Sea King gave the Royal Navy a genuine all-weather search and rescue capability.
The pilot workload during genuine emergencies was high enough that crew fatigue became an operational consideration.
Pilots flying night rescues in deteriorating weather managed navigation, systems monitoring, hoist operations, and fuel state simultaneously.
The Tiger entered service in the early 2000s with the French, German, and Australian armies.
The glass cockpit generated heat at a rate the environmental control system could not consistently manage.